Good morning, Miss Wilcox. The former math professor turned CEO Samantha Blackwell has become a billionaire within the last few months due to her company's fame. However, she has gathered this wealth through suspicious means. We believe her company is illegally changing students' AP scores from 5s to 3s, then changing her clients' scores to 5. Your mission, should you choose to accept it, is to infiltrate her lab and gather evidence of this crime. I've already assembled a team. I have Agent Hart standing by, awaiting your word. If you or any member of your IMF team are caught or killed, the Secretary will disavow any knowledge of your actions. Good luck, Ava. This message will self-destruct in 5 seconds.
2 hours later.
Okay, so here's the plan. I've sent you a USB flash drive and an earpiece that we can use to communicate with. I'm going to sneak into the company dressed as the new intern. I've already acquired an ID badge and a fake name for this part. I will follow the path and gain access to the main terminal and download the floor plan from there. That's where you come in. You're going to sneak into the lab through the back door. From there, I will guide you through the lab to the computer terminal where you can download the evidence by sticking the USB on your desk into the computer. It is specially designed to delete the file off the computer while copying it. Then, if you leave through the door next to her desk and manage to not run into any guards, then you may escape successfully. Samantha has been known to use Taylor polynomials in her code, so make sure you know how to solve them.
Okay, will do. I'll meet you at the base. Remember, we have less than 24 hours to infiltrate it.
3 hours later.
Okay, I'm in. The security feed is now playing on a loop. The cameras won't catch you.
Got it. Thanks, Haley. I've jumped the fence. What do I do now?
The first door to your right is going to lead to the kitchen. You need to lockpick it. Be careful of any cooks. Now continue forward until you see the crossroad in the hallway.
Which way now? Right or left?
Left. Samantha keeps the computer with the formulas for Taylor polynomials at the end of the hallway.
I found the computer. But I can't access the files. There's a program asking me to enter the coefficients for a polynomial, and another file with tables and graphs.
That's the code. In order to open the files, you first have to solve multiple problems involving Taylor polynomials.
Wait, how? I don't know how to solve Taylor polynomials.
What do you mean you don't know how to solve them? You trained for this.
I may have forgotten it, so can't you remind me?
Fine, but only this once. Taylor polynomials are a means of approximating functions around a specific point using polynomials of the nth degree. I've sent you the definition of the nth degree Taylor polynomial. You should be seeing it on your screen right now. I have also sent you the definition for each variable. Similarly, a Maclaurin polynomial is just a Taylor polynomial where the starting position c equals 0. Wait, I think I hear something.
Haley? Haley? What's going on? We gotta finish this mission. Okay, for the first problem, I need to compute the third degree Taylor polynomial of natural log 1 plus x about x equals to 0. Then I have to enter the coefficients into the formula. Okay, I'm going to say that f of x equals to natural log 1 plus x. The Taylor polynomial is centered about x equals to 0, so I need to plug in 0 into the equation for f of x, which will equal 0. Since it is a third degree Taylor polynomial, I need to find all the derivatives of f of x up to the third degree, starting with f prime. Because f of x is a natural log, the derivative would be du over u. In this case, it is 1 over 1 plus x. Again, I need to substitute in 0, so f prime of 0 is 1. Now to find the second derivative, I'm first going to rewrite f prime as 1 plus x to the power of negative 1. When deriving that, I move the negative 1 to the front and subtract 1 from the exponent. Normally, I'd also need to use chain rule to derive the x inside the parentheses too, but because the derivative of 1x is 1, I'm going to leave it be. Plugging in 0, I get that f double prime is negative 1. To derive f triple prime, I take f double prime and I move the negative 2 to the front. Then I subtract 1 from the exponent again, and so when I rewrite the equation, I get 2 divided by 1 plus x cubed. Then I plug in 0 and get 2 for f triple prime. To write the third degree Taylor polynomial, I just follow the formula and plug in the values of f of x and its derivatives at x equals to 0 as the coefficients. Okay, so now that I've solved the problem, I need to enter the coefficients into the formula. The coefficients for this Taylor polynomial are 0, 1, negative 1, and 2. The next problem says, given the graph and table in figure 1, I'm assuming it refers to this. Compute the third degree Taylor polynomial for f about x equals to 0. Enter the coefficients into the formula. The graph and the table already have most of the values I need to compute the third degree Taylor polynomial. Looking at the graph, f of 0 is 3. To find f prime of 0, I need to find the slope of the tangent line at x equals to 0. Using the points negative 1, 5 and 1, 1, I can calculate the slope by dividing the difference in y coordinates by the difference in x coordinates. The table provides the other two derivatives I need, f double prime of 0 and f triple prime of 0, which are 3 and negative 23 divided by 2 respectively. Negative 23 divided by 2 in decimal form is negative 11.5. Now I have all the values I need to create the third degree Taylor polynomial. I just followed the formula and plug in the values of f of x and its derivatives at x equals to 0 as the coefficients like I did in problem number 1. I've solved the second problem. Now we need to enter the coefficients into the formula again. The coefficients for the second Taylor polynomial are 3, negative 2, 3, and negative 23 over 2, which as a decimal is negative 11.5. The third and final problem is, given the table and equation in figure 2, I believe it would be this, compute the second degree Taylor polynomial for h of x centered at x equals to negative 1. Enter the coefficients into the formula. Okay, so I'm given the equation that h of x equals to 3x plus the integral of g of x from the endpoints 1 to x squared. Plugging in negative 1 for h of x, I get that h of negative 1 equals to negative 3 plus the integral of g of x from 1 to 1. Since the integral has the same value for both of its endpoints, the value of the integral is 0. Now I need to find the derivative of h of x. The derivative of 3x is 3. The derivative of the integral is g of x squared times 2x. I have to derive the value inside the parentheses too because of chain rule, which gives me the 2x. Plugging in -1, I get that h prime of -1 is -7. To find h double prime, I need to use the product rule to expand out the derivative. I first derive g of x squared, which is g prime of x squared times 2x, and then I multiply that by 2x again. Then I add the derivative of 2x multiplied by g of x squared. When I plug in -1, I get that h double prime is equal to -6. Now I just plug in the values of h of x and its derivative at x equals -1 as the coefficients like I did in problem number 1 and 2. Although this time the formula looks a little different. Since it's centered at x equals to -1, the Taylor polynomial has x plus 1 instead of x like the previous problems. Okay, for the final Taylor polynomial, the coefficients are -3, -7, and -6. The file has been successfully copied and deleted.
Two hours later.